And so, welcome everyone. So today we have Marco here with us to talk about an amazing project, which is called Project Bicep, which tends to basically come and work on top of ARM, replace ARM. Let's see what Marco has to say for us. Okay, I'd just like to show here some slides. So basically, oh, it's not this one. It's basically the next session. So we're going to have a January, February, and March editions that we already have dates, schedules, and we already kind of have like stuff aligned. And probably even this week it should get out and they should be published on the Meetup page that you have down there. So keep an eye on your emails and keep an eye on the page, and you're going to get those sessions. As you know, we are a Portuguese community, so what we do is when we have sessions made by Portuguese speakers, the session is entirely in Portuguese. We are very clear on that on the meetup for the event. This session is in Portuguese and this session is in English, so we learn and we're going to do that because we had some sessions in Portuguese that we were not clear that they were in Portuguese and vice versa, but we learned with our mistakes, and there you go. We have there, we're going to publish that very clearly. That this is the expectations. In March, we have another English session. That's not going to be about Databricks. It's going to be another topic, but well, just I think I did a wrong copy paste. But it's going to be in English, so we're always, everyone is always welcome to the Portuguese and the English sessions. I usually attend also some sessions from a Greek community, and my Greek is not the best, to be very nice and polite with myself. But you always get something, to be honest, and you always get something, and at least you learn a little bit. Also, you learn the language too. And so today we have Marco Obinu, that it's our amazing speaker here today. He's an advisor engineer at SoftJam. Did I say it correctly, Marco?
Yes.
Okay. Happy flag. Okay. and basically I think Pedro also wants to do some questions. Okay, but I think I can start. Can you present yourself just a little bit? Talk about yourself. How do you started in this Azure journey, and why Azure? Why not other technologies when we live in a world full of amazing technologies?
Okay. Well, I'm Marco. Nice to meet you. I'm from Italy. I live in the northern part near Genova. And I work as an advisory engineer in SoftJam, which is one of the main Microsoft partners here in Italy. I work mainly with Azure solutions since my company was one of the first Italian partners that invested in Azure. In the past, we started working with it in 2013, I think. And I work with Azure. I've worked with Azure since at least 5 or 6 years. Right now, I'm passionate about the Microsoft Data Platform. I love Azure SQL Virtual Machines and the Azure SQL Database, and I love also Azure in its complexity. And I'm an Azure MVP from this year, from last July. Well. What is an advisor engineer? Well, till a few months ago, I was directly involved in delivering projects for the customers. I'm an IT pro. Basically, I work in the infrastructure field. I'm not a developer, so I'll probably say something wrong talking about Bicep and dev tools. Now I moved into the engineering department, and I basically design and present to the customer the most innovative solution we are proposing for them. So I think that's all. In my spare time, I'm just a geek. I love everything about the do-it-yourself stuff. I have a workshop. I love woodworking, metalworking, carpentry, and so on. Well, in my spare time, that is not so much because I often involved in community events, and I also have a couple of children, so it's a bit hard to find the spare time now.
Yeah, I totally relate with that. Pedro, it's up to you now. You have a question?
Okay, hi Marco. I'm going to throw you a curveball. If we go to Genoa, what definitely should I eat?
Ooh, I love to eat, so it's easy to answer. Well, I think that one of the most famous dishes here is pasta al pesto, which is a Italian pasta. You can have it in different format with a basil sauce. That is very typical. Or you can eat focaccia, which is it's a soft. It's hard to explain it in English. It's like some Genoese people can kill me for what I'm saying right now. It's like a white pizza, more soft and with a lot of oil, and you can also have onions on it and so on. It's fantastic for a break or for breakfast. You can insert it in your cappuccino, and it's fantastic.
Okay. So I'm going to have some dinner, guys. Nice to meet you. Bye. I've seen, jokes apart, Marco, I've seen that you work a lot with SQL Server and with data platform. Do you think that we can do infrastructure as code when we are talking about SQL Server and data in general?
Yes, I think so. I prepared an ARM template that I'll show you later during the presentation. Because in the past I usually went to different several customers in a week, and I had to deploy even complex scenarios with Azure SQL virtual machines, since a lot of our customers are still on infrastructure as a service. And in the past, the SQL Server images you could find in the marketplace were all except be made with best practices in mind. You usually had to deploy your SQL Server virtual machine and then apply a lot of changes to make it compliant with best practices. So I developed an ARM template that I used both for dev and test environment and for production environment that deploy the virtual machine with the right storage layout, and then with the PowerShell desired state configuration applies guest OS and SQL Server configuration on top of it. So you can for sure do it.
Okay, so last question from my side before I drop the ball to Tiago again. If I wanted to start building my AIC, where, in your opinion, where should I start?
Well, it depends. I started working with ARM templates 4 years ago because I didn't know any other tools to do it, and I was mainly working with Azure, so my interest went there. And if you want to start, you should be able to find a Microsoft Learning path to start working with ARM templates, or you can use one of my GitHub repos for with some example. I'll link it in the last slide, so attendees will be able to find it.
Okay, okay, thank you, Marco. And Thiago, now I'm going to drop the ball to you, guy.
Okay, so I just have one question. What is your favorite Azure service and why?
Well, it's another question, but I know this can seems legacy, but I really love virtual machines because they have all the complexity of IOPS, Azure Compute Unit, different families, different features. I love very much to work with them, even if I completely aware that the future is on the platform as a service.
Mm-hmm.
I will deliver a session on a event on Saturday. I think you also will be a speaker for the IT Pro Dev conference in Greece, Thiago.
Yes, I'm a speaker.
And the session will be the title of the session is Myth Busting Azure SQL Virtual Machines, and I go through the comparison between the complexities of a virtual machine environment in comparison with the Azure SQL database offering, and it's interesting. I love that part. Also with platform as a service databases, I love to understand how the storage layout is composed, what about the compute power and so on. I like that kind of details.
Mm-hmm. Okay, great. That was great. I think we have it all. So maybe we can start with our session. No? Yes, Pedro.
Oh, sorry, I was muted. Yeah, sure. I think
yeah,
we are on time.
Cool. So Marco, you have the stage.
Okay, just let me share my desktop. Okay. Okay, can you see my intro slide?
I can see it perfectly.
Okay.
Yes.
Yeah.
And now
yeah.
I switch on the VS Code. Is okay?
Mm-hmm.
Okay, perfect. Let's go. So welcome everybody to this session about infrastructure as code on Azure. We will talk about ARM templates. We will see the current state of the art of this tool, and as well we will introduce some basic concepts about infrastructure as code. And then we will have a brief overview of the project Bicep, which is the new domain-specific language that Microsoft introduced to save us sometimes reducing the complexities of ARM templates. We can just step into the ARM template part, but before doing it, let's talk just a little bit about infrastructure as code. What is infrastructure as code? Well, it is an approach that permits you to describe your infrastructure and to deploy your infrastructure via declarative syntax included inside the scripts. By using script to deploy your infrastructure, you can leverage the tools that are normally used by developers, like version controls tools or IDE and so on. By versioning your scripts, you can track the changes you are applying to your infrastructure during time, as well as you can automate deployment by inserting these scripts inside CI/CD pipelines. And this can create a strong link between your application code and the underlying infrastructure. You can be sure that your new version of the application goes live only if the underlying infrastructure is there to support it. Now, when we talk about infrastructure as code on Azure, we talk about ARM templates that are the native infrastructure as code solution provisioned by Microsoft some years ago. Basically, what is an ARM template? It's a JSON file that contains the declarative syntax. When you author the JSON file and you completed it, you can send it to the Azure Resource Manager backend, and the Resource Manager will translate all the JSON stuff into REST API calls to the resource providers. And then the resource provider will provision the resources that you are asking for. Being the native solution for Azure deployment doesn't mean that ARM templates are the only infrastructure as code option you have for Azure. I can think about a lot of other instruments. Probably the most famous is Terraform. And all of these third-party tools have their advantages. For example, Terraform is really interesting because it works with different providers, and so it can provision infrastructure in different environments. You can deploy Azure resources as well, AWS resources, and so on by using the same HCL syntax. Now, I started working with ARM templates almost 4 years ago, I think, because I was looking for a solution that permits me to easily create a demo environment for attendees of my sessions. Well, when I prepare a session, I want that the attendees can redo all the stuff I'm explaining at home just to test and to try it. And I don't want to write a 10 pages blog post about how to implement the environment that you need to support the feature I'm talking about. So I spend my time to author an ARM template, and then I share it with my attendees so they can focus only on the interesting part of the speech and not in the environment preparation. I also use the ARM templates during my day-by-day job activity because it permits me to be fast and consistent in the deployments I do for customers. I'm a consultant. I usually visit more than a customer each week, and I need a way to easily deploy my solution to the customers and in a consistent way. And additionally, I can archive all the scripts and all the parameters I used for each customer. And after a while, I am able to understand what kind of deployment I did that specific day for that specific customer. That said, there are at least a couple of other reasons I like to work with ARM templates. First of all, they have a complete coverage of all Azure feature. When Microsoft releases a new feature for Azure, immediately or in a short while, you're able to find a way to describe that feature inside an ARM template. This is not always true for third-party solutions. It happened to me a few months ago that I wasn't able to assign a property of an Azure machine learning workspace via Terraform because the provider was not aware of that feature yet. Then another good reason to learn JSON templates is due to the fact that they are very well integrated with the Azure platform. If you create something via the portal and you want to export it, you end with an ARM template. If you are using blueprints or you're deploying Windows Virtual Desktop environment, or for example, if you want to implement CI/CD for Azure Data Factory, well, you're working with ARM templates. And so even if your main infrastructure as code tool is a different third-party tool like Terraform, then you still need to understand a little bit of ARM templates to work with certain Azure features. In the last period, ARM template received a lot of developments that made them a complete tool for infrastructure as code. Some of these additional feature or new developments were intended to for reducing the complexity of authoring ARM templates. I can show you here something about the Azure Resource Manager, the ARM extension, the official ARM extension for VS Code. With this, you can create a JSON template from scratch in an easy way by leveraging code completion, snippets, and so on. You can just write down ARM and obtain the schema and of the template. You can go into the parameter section and write a new parameters, or you can create a resource. It's quite easy, and you have code completion for a lot of stuff. For example, you can look for each resource, you can find live the right API version you're looking for. It's very interesting. That said, ARM templates have also their cons. I love this tool, but I can understand they have some limitation. For example, they're Azure only. As I was saying, if you work with Terraform, you can reuse the same HCL syntax with different target for your deployment, while with ARM templates, you are working on Azure and you are working only on Azure. Then I can see that ARM templates are complex in terms of verbosity. In terms of the rigidity of the schema, you have a specific schema. You need to specify a parameters section for parameters, a variable section for variables, and so on. And this can add complexity when you are working with complex deployments, and even if you work with linked templates, and so you're trying to split your huge template into several small files. This can be an issue with the reusability. If you want to reuse part of your code for a brand new template, it can be hard for you to find all the stuff you need to cut and paste between different templates. I can show you an example here too. Here you can find my ARM template about optimized SQL Server VM for Azure. This is the template I was talking about in the intro. As you can see, it has a lot of parameters since I use it in a whole different lot of different scenarios. So I need that it can be easily adapted in different ways. And if you look at the JSON, this stuff deploys only a virtual machine with a lot of optimization, PowerShell desired state configuration, and so on. But a single virtual machine with its complexity will const about 1,400 of lines. It's a huge template for a single virtual machine. And if you need to cut and paste part of this template into another one, it can be a tedious task. Let's jump back to the slides and let's introduce Azure Bicep, Project Bicep. Well, Microsoft is aware of the complexity of the complexities I was talking about before, and introduced this new domain-specific language that target ARM deployments. It doesn't want to replace JSON ARM templates. It won't be complementary for JSON ARM template. You author Bicep file by using a less verbose syntax, a more readable syntax, and so on. And when you're ready with your Bicep file, you need to use the Bicep CLI, a console application that transpile your Bicep file into a JSON ARM template. This has two advantages to me. First of all, you can reuse your JSON ARM knowledge, because in the end, you're still working with JSON ARM under the hood. And on the Azure side, the introduction of Project Bicep doesn't require any specific change, because the ARM part of Azure is still working with JSON files. You can consider Bicep file as your source for your infrastructure as code solution, and then when you have transpiled them into JSON, you can consider JSON as an artifact that is ready to be processed by the ARM backend. What do you need to start working with Bicep? You need at least the Bicep CLI. This is required. This is a cross-platform console application that can translate Bicep file into JSON ARM templates. And recently, it was added the opposite function. You can decompile JSON ARM template files into Bicep files. This should help you to speed up the introduction of Bicep in your environment. Then you can author file with your preferred IDE or your preferred editor, starting with Notepad, but your life can be easier if you use VS Code with the specific Bicep extension that act in a similar way in respect of the ARM template extension I presented before. So it had snippets, IntelliSense validation of your code, and so on. It's an optional feature, but it's highly recommended. Here in this link to the official Bicep repository, you can find the installing instruction for every different operating system. Now, let's see a quick comparison between the different parts of an ARM template with the corresponding part in Bicep. On the left column, you can see the JSON representation of, for example, the parameters block. And on the right column, you can see the Bicep representation. Starting with parameters, you can see here we have a parameter blocks, where inside this block you have to specify all the parameters you want to use. Bicep is easier in this context, since you only need to declare a parameter, you only need to specify the keyword param, followed by the name of the parameter, its type, and eventually its default value. And you don't have to use a parameters block. You can define parameters everywhere you want inside your Bicep file. This could help you with readability, since you are able to declare parameters near the resources that are consuming them. When it's time to recall the parameter value in Bicep, you simply have to reference the parameter name. While with JSON, you have to use the parameters function and then the parameter's name. This syntax for Bicep is shorter and easier to be read. Anyway, you have all the modifiers you need to create complex parameters. For example, you can create secure string parameters with this modifier, or you can add more complexity by specifying allowed values, default values, and the metadata description. Even with these complex parameters, the syntax in Bicep is easier to be read due to the fact that you are avoiding the double quotes and the commas and so on. So it's shorter and easier to be read. When we move to the variable blocks, again, in Bicep file, you don't have to declare a variables block. You can simply declare variables wherever you want in your file. And you can assign a static value by declaring the variable with the var keyword followed by the name of the variable and then assign the static value, or you can just reuse the ARM template function you already know, and this goes in the direction of reusability of your knowledge. So for example, in this case, I'm using the resource group ID for this variable. And this is the same function I'm using here in the JSON representation, but without the square brackets and the double quotes. Regarding concatenation, you can concatenation are one of the most used functions in ARM templates, and can be one of the more of the longer function you can use, because you need to concatenate a lot of different values to compose unique names and so on. Even if you can reuse this syntax, concat, static values, and then parameter values, even in Bicep. In Bicep, you can also leverage a new syntax for concatenation that use string interpolation, and with this form you obtain the same result with less characters. And regarding the use of the variables inside the your Bicep file, again, it's like for parameters. You simply have to reference the name of the variable, while in JSON you need to use the variable function. And this is a game changer here for me, because I usually have to change parameters into variables in my templates, because probably I don't do enough preparation for my templates. So I need to, while authoring, I need to convert the parameters into a variable. And with JSON, you need to go into the parameters block, cut the parameters and paste it in the variables block, and change the way you declare the object, since you are moving from a parameters to a variable. And then you have to jump through the code and find all the occurrences of the parameters, because you need to change the parameters function to the variables one. With Bicep, this last step is not needed, because you recall a variable value in the same way you recall a parameter value inside your code. Now it's time to talk about the resources. Here you can find the way you should implement to define a resource inside the Bicep file. You need to specify the keyword resource, followed by a symbolic name that acts as a nickname of your resource and permits you to reference it later in the deployment. Then you need to specify the type and the API version of the resource you want to create in this form with the hat in the middle. And then inside the curly brackets, you have to specify all the properties of the resource you are creating. And these properties are the same you can find inside the harm template reference. You can see here. This is the harm template reference where you can find all the schemas of all the different resources you can create inside an ARM template inside Azure. You can refer to, for example, for this schema for an automation account, and you can find the properties you need to specify inside your Bicep file with their allowed values. You can simply use the same structure by simply replacing double quotes with single quotes when it's needed. Or if you like me, find this piece of documentation a bit hard to be read, because sometimes in more complex resources, it can be trickier to understand which kind of value you need to specify in each property. Well, you can just apply some kind of reverse engineering by using the Resource Explorer inside the Azure portal. With this tool, you can browse your subscription and reach your resource group and go through the single resource where you can have a live representation of the JSON that is under the hood, that describe under the hood the resource you are looking for, and you can find the current value for each property. That said, you need simply to reuse the same properties and the right values inside the curly brackets. Additionally, using a symbolic name can simplify your life if you need to reference a properties of a resource you have previously deployed in the ARM template or in the Bicep file. Because if you need to do this in JSON ARM template, you need to use the reference function and then the resource ID function followed by the name of the resource you want to reach, and then you need to find also the property you want to expose later in your deployment. With Bicep, this stuff is simplified, because you can simply reference the symbolic name of the previously created resource. Then you add .properties, the name of the property you want to expose. This is more readable, and when you do this between resources that have a parent-child relationship, or when you need to access a property of a previously created resource, and you need a dependency between those resources, by using this syntax, Bicep is able to create an implicit dependency. When you translate this syntax between Bicep and ARM templates, you'll find a depends on dependency inside the ARM templates, and this is really useful. Last but not least, there's the output block. Again, in Bicep, you don't need to declare an output value. you simply declare an outputs block, sorry. You simply need to declare your output value, and you can do it wherever you want in your file. Now, we had a brief overview, but I think that it can be easier if we switch to some code, and we'll have a look about on how to work with Bicep. Well, here I have a VS Code with the extension, the Bicep extension already loaded, and I previously installed the Bicep CLI in this machine. So I'm ready to start, and I can launch my deploy script. Also, this small repository will be shared with you at the end of the presentation. Okay, let's start by invoking the Bicep CLI. And here you can find the output of the help command. You can see here that it accepts the build command to transpile Bicep file into ARM JSON files, and it accepts the decompile command to do the opposite thing, and so translate JSON ARM template files into Bicep files. Okay, now I'd like to show you how we can translate a simple ARM template into a Bicep file. How easy it is to translate live this kind of files. Where here we have a simple ARM template that accept a bunch of parameters and provision an Azure SQL database logical server. And then inside that logical server, it adds a SQL Server database, an Azure SQL Server database that is a child resource of the logical server. Now, as you can see here, I'm accepting with this template, I am accepting an environment parameters that accept both the test or prod values, and depending on that parameters, I'm using here an if function to define the tier of the Azure SQL database I'm deploying. If I'm in a test environment, I'm deploying an S0 tier. Otherwise, I'll deploy an S3 tier. Now, let's start translating it into a Bicep file. Close something. Okay, we're ready to go. Just for the sake of simplicity, we will maintain the same structure in the Bicep file. So we will start declaring parameters and then variables and then resources, and last but not least, the output section. Even if we are able, as I was saying before, to declare parameters or variables or outputs wherever we want inside the file. Let's start with parameters. You simply need to use the param keyword, and you can start specifying the administrator login parameters, and then you can add an additional param for administrator login password that need to be a secure string in this case, and so I'm adding a modifier to enable the secure string. As you can see, you have code completion, auto completion that make your life easier with the VS Code extension. Then let's go on with another param, which is the database name. And we need now to define the parameter related to the environment. So let's declare it, environment, that is a string, and we need to specify some modifiers also here by let's start with the metadata description. And we can use target environment. And then we need to specify allowed values. And it should be whole right now. We have 14 rows instead of 26. Okay, on the other side, we have also a couple of rows with comments, but it's not a problem at all. We can also add comments here. They're a supported syntax. Okay, let's move on and let's go with the variable section. It's easy enough to declare the variable, and we need to specify SQL Server name variable. That here use a concat to create a unique name for our SQL Server. Now, since I'm a lazy guy, I would go with a cut and paste of the syntax used in the JSON template. As you can see here, it's completely supported for this. Then I need to specify a new var for the collation, and I'm going here and cut and paste the value of my collation. And now it's the moment to clear the resources. Let's start with the Azure SQL Database Logical Server. We need the resource keyword followed by a symbolic name for the SQL Server. And then we need to specify the resource type and the API version we want to use. We can use this fuzzy search to find the right API version and resource type. And okay, now inside the curly brackets, we need to specify the name of the resource that we have defined inside our variable. And then we need to define the location of our SQL Server. And to do this, we will use the resource group function and the location properties. So the logical server will be deployed inside in the same location as the resource group. That is the target for the deployment. Now let's move on and let's add the properties block where we can specify the administrator login and its administrator login variable and the administrator login password. Quite easy without completion. Okay, that's all for the logical server. Now we have to move into the Azure SQL Database, which is a child resource for our logical server. And so we need to specify a resource. We add a symbolic name, and then we need to specify the resource type. Okay. Now we are creating a we are just creating a child resource. The database is a child resource for the logical server, and so its name has to follow the syntax where you specify the name of the server / the name of the database. You can see this syntax here where I'm using the concat function to use the SQL Server name variable / the name of the database I specified in the parameters. Now I can cut and paste again my concat function, but here I would like to leverage the new syntax with string interpolation since it's easier to be read. So I'm just using this syntax to retrieve the SQL Server name. And by using this syntax, I'm also specifying that an implicit dependency, we will need an implicit dependency between the database and the logical server. And then I'll add the database name variable. And that should be enough to create our composite name for the resource. Then I need again the location, and I use again the resource group location function. Okay, and now we have to add the SKU block that determine the tier of the database we are creating. To do this, again, we can move here and cut and paste the if function, the whole if function, but again, we can leverage an easier way to write this kind of statement in Bicep with the native ternary operator, so we can just specify the property we want to add, and then we can add this ternary operator that is saying that if environment is equal to test, then use an S0 as value for the name. Otherwise, you can use an S3 tier for the name property. And then let's go on, add the properties block for the collation, where we specify the variable, and that's all for the resource. Now, last part is related to the output section. We simply, here we have an output block that outputs an object with a couple of properties. One will retrieve the fully qualified domain name of the logical server we have created inside the deployment, while the other property will reference the name of the logical server. Let's do the same stuff in Bicep, and we can create the output SQL parameters. We declare it as an object, and then we can create the properties where we have SQL URI, that is the fully qualified domain name, and instead of using this complex syntax, we can simply use the symbolic name of this logical server dot properties dot fully qualified domain name. And again, for the SQL server name, we can simply reference again the symbolic name for the logical server dot name property. And that's all. Our Bicep file is here and is live. I can't see any red sign, so it should be ready. We have 84 lines on the JSON part and 43 on the Bicep part. It's an interesting difference, I think. Now, let's move on and let's compile it. I'm using the Bicep build command to compile my newly created Bicep file. And now we can compare our source JSON with the new just compiled JSON. And you can see, if you analyze it, you can find only minor differences. Well, of course, there are not the comments, and as in some places, the order of properties is not the same, but those are minor differences. The newly created JSON file starting from our Bicep behaving the same way as the original ARM template. Okay, that's all for the first comparison. Now I can show you how to decompile your existing JSON file. Here you can find a very simple ARM template that create a simple storage account. You can use it with the Bicep CLI with the decompile command to create a Bicep file starting from the JSON file. Here it raises a warning since this part is still in a very early stage of deployment development, so it can produce some errors. But if you go here and look at the newly created Bicep file, it works, and it could be a good starting point for you to convert your existing ARM templates into Bicep. Now, let's talk about modules. I said before during the slide presentation that one of the main concerns about ARM templates is related to their complexities in more structured scenarios. You can leverage linked templates, nested templates, and so on, but to me, there's still a little bit too complex to work with all this stuff. Bicep add the support for a module that it can be very useful to keep the readability and the reusability of code very easy. To define a Bicep module, you simply create a simple Bicep file. You don't need to use any specific syntax to create a module. You simply author a normal Bicep file. Here I created a Bicep module for to create an Azure SQL database. This accepts some parameters, including the name of the server, of the logical server. It needs to create the composite name of the Azure SQL database resource. And then I have a module that deploy the logical server, again with parameters and values, and this one has an output section to expose the fully qualified domain name and the SQL Server name for the following module. Then you simply need to create a parent Bicep file. I named it main.bicep, where you ask for the parameters you need and you define all the variables you need. Then instead of declaring resources inside this Bicep file, you use the keyword module to reference the Bicep modules file. You use the keyword followed by the symbolic name, and then you need to specify the path to the Bicep file. And then inside the curly brackets, you need to specify the name of the deployment, and then you have a params block where you can specify all the parameters that the module is looking for. As you can see here, I'm using the SQL Server module to deploy the Azure SQL Database Logical Server. Then I'm using here the database module to deploy the child resource, the database resource. And by using this syntax, by referencing the symbolic name of the logical server module, I'm implicitly adding a dependency between the two resources. If we go here and look to the JSON that can be easily generated by using this build command, you simply have to build the parent Bicep file, the main Bicep file. You can obtain this main.json, which simply is a long JSON file which contains inside a couple of nested deployment. Each module is represented here as a resource type of deployments. So it's a nested deployment with all the stuff you need to deploy the logical server. And we have here a second nested deployment for the database object that has a dependency on the deployment related to the logical server. So with this, you can keep the structured approach very easy to be read and understood. Now, for sure, this JSON file is not as good looking as it could be if you author directly a corresponding JSON file without nested templates. But this is not a concern, since your source code is inside Bicep files, and you can consider this as an artifact. So even if it's not so easy to be read, the JSON you have generated, it's not a problem, since you're working mainly with Bicep files. Okay, we can just conclude with another example regarding different scopes. You can then look at at this example on my repository just to understand them better. Okay, you should know that with ARM templates, you can target different deployment scope. You normally deploy resources at the resource group level. If you don't specify anything inside the ARM template, your ARM template is targeted to a resource group. Then you can instead specify a different scope that can be, for example, a subscription or a tenant, to deploy resources that are at that kind of scopes. Here I did the same stuff with Bicep. I prepared a simple module that deploy a storage account, and then I prepared a parent Bicep file that has a target scope at the subscription level. Then inside the subscription, I create a resource that is a resource group. So I'm with this deployment, I'm creating a resource group, and then I'm using the module for the storage account, and I'm targeting it at the resource group level by using the resource group name of the resource group I previously created. This results in a single longer JSON file that is targeted. You can see here in the schema definition, is targeted at the subscription level, and it deploys a resource group, and then with the nested templates, with the nested deployment due to the module, it deploy the storage account at the resource group level with the dependency upon the resource group. Okay, that should be all. Let's jump back to the slide and let's talk about the limitations and the roadmap. Well, we are currently at the second release of Bicep, the 0.2 version of Bicep. The first release was created on August, if I recall well, and in a couple of months, Microsoft was able to reduce the number of limitations in a very good way. The development of this project is very fast. Actually, we are still lacking the support for the copy or condition properties, so you cannot create a copy loops inside your Bicep file, not yet. And for single line objects and array. Additionally, the Azure CLI and the Azure PowerShell module don't have native support for Bicep files yet, at least. It's planned. So the meaning of this is that if you now need to deploy your Bicep file, you need first of all to convert the Bicep into a JSON file via the Bicep CLI, and then you have to deploy the transpiled JSON ARM template via, for example, Azure PowerShell. In the future, Azure PowerShell will be able to accept directly the Bicep file, and it can convert it on the fly and send it to ARM for the deployment. And last but not least, currently, Bicep is not production ready, is not yet production ready. It does not, it's not covered by Azure support, so you cannot use it in production. But as I've shown you, you can already do a lot of stuff with that, and you can start learning how to convert your JSON templates into Bicep files. This is the roadmap. The third release should arrive at the end of January next year, and aim to have the feature parity with the JSON ARM languages. So we should be able to translate all of our JSON ARM templates with that version. And additionally, what we should expect for the future, well, this DSL is targeted for ARM deployment, but this doesn't mean that it will only be dedicated to Azure resources. We will probably obtain in the future a sort of extensibility for the DSL that should make us able to complete the last mile of our deployment, for example, and so deploy an end-to-end solution to Azure. For example, if you are deploying an Azure container instance, then you will probably want to deploy an image on that container instance, and we will probably be able to do this via Bicep in the future. Okay, I think that's all. I leave you with some resources here. I suggest you to visit the official repo, and that is also the official documentation repository right now. And you can find all the instruction to start working with this DSL. I can suggest you to have a look at the Bicep Playground if you want to just have a quick overview of this word. This is a nice tool, a nice website where you can load different templates, and you can see the direct comparison between the different syntaxes, and you can do live editing, and when you write something in the Bicep field, you automatically it's translated into ARM. You can start working with this, but here you now have the VS Code extension, so you need to know the syntax you are using. Okay, then as promised, you can find here the GitHub repositories you can use to start working with Project Bicep. And I have also a NARM template repository with some example, starting with some basics example to more complex ones. Okay, that's all. Is there any question?
Okay, Marco. Let's see if we have any questions here on the chat. People seem to be very quiet today. Maybe I can drop you a question. I don't know if you have the answer for it, but
okay.
We had ARM templates, right? So why did we add the need for Bicep? Where did it came from?
Well, Bicep has been introduced to reduce the complexities of ARM templates. You can still working with ARM templates, but their complex to maintain and to reuse code. They have a lot of rigidity, and in complex scenarios, in enterprise grade scenarios, working with the harm templates can be complex and a little bit just time consuming, I think. So Bicep is here to simplify the authoring part and to improve the reusability of code. Working with module, I found that Bicep modules are very, very quick to be understood and to be implemented in comparison with a linked template solution with a harm templates.
Okay. Tiago, I don't know. Do you see any more questions here, guys?
I don't see any question, but people can do questions for sure. But I have a small tiny question is, so Bicep basically translates to ARM, and then we know that ARM is it's one inch in the back, etc. So one of the things that this is more like some stuff that is like in the community now that I already heard is like, oh, Bicep, Microsoft is going to replace ARM with Bicep. It's like, come on. Okay, so it's not okay. So, but yeah, I already played around with Bicep a lot, and it is pretty cool. Okay, so it's definitely something that we need to start to check out if we are working with infrastructure as code, etc. But my question is comparing Bicep with Terraform. Okay.
Mm-hmm.
Yeah.
Mm-hmm.
And it's like we know that, okay, Terraform, also works with AWS. Okay, okay, great. But why not onboarding, Terraform instead of building something new like Bicep? Okay, I don't know if you want to give like your opinion on that, Marco.
Well, I can understand your question. And the official reason to propose a new DSL instead of improving an existing tool, Terraform, is that the team preferred to let the user the availability to choose between different tools instead of focusing on only one tools that will go over in the development and be more suitable for Azure deployment. I like very much Bicep since it has a similar syntax, a similar approach to Terraform. And but it also has all the benefit I mentioned before about harm templates. If I'm able to do something with the harm templates, and I'm usually able to do anything in Azure with the harm templates, I can do the same with Bicep without any issues. While with Terraform, I need to wait for the provider that become updated to support new features. And additionally, for my usage pattern, I prefer to work with harm templates because for me it's easier to introduce a specific part of my infrastructure without describing all the content of the resource group. In my experience, and it's a short experience, it's possible I did something wrong in the past. In my experience with Terraform, you need to describe all the already existing resources inside the resource group because the instruments need to create the state file of your target of your landing zone. Harm doesn't need this part because it's able to to chat directly with the Azure Resource Manager. So I think that this is another good point for ARM templates and implicitly for Bicep.
Cool. We have a question here. Yeah.
Zeto is joking about Tricep, which will be the newest flavor joining Bicep to AWS. I think you're mixing Bicep with Azure Arc, so we can manage AWS with Bicep.
But we have another question here. Is like Bicep advantages for Terraform and disadvantages? If you see, well, I think we already covered kind of that. No.
Yeah.
I don't know if you want to say more about that.
Yeah, well, actually, I've already said all the stuff I've seen right now. I'm not a big Terraform user, a huge Terraform user, so probably I can't go deeper in this topic. But to me, well, Bicep offers the same advantages that ARM templates has over Terraform. Mm-hmm. But with a reduced complexity. So I'm looking forward to translate all my ARM templates into Bicep file. When we'll obtain the feature parity, I can see a reason to still working with ARM templates, if not strictly necessary or requested by the kind of deployment you are doing. Well, as I was saying before, if you work with the CI/CD stuff for Azure Data Factory, well, it provision you ARM templates, and I don't think that part will be translated into Bicep in the near future. But that's a reason to keep going with the ARM templates. But in any other scenario, for my scripts, for my solution, for my demo, for news talks and so on, I will move to Bicep for sure.
Mm-hmm. Okay, thank you. And I personally don't have any more questions. I think I'm good. And Pedro, do you have?
Well, I'm just curious to kick the tires on Bicep and see how it works. I already used the Bicep playground that Marco shared, and I actually tested some ARM templates that I have here on my laptop from the Azure template gallery, and it's kind of cool to see the differences between the demos that Microsoft provides on the Azure templates and what Bicep can and cannot do. I actually broke a Bicep trying to decompile a policy definition, but yeah, it's ongoing. It's an ongoing language.
Yeah, the compile part is quite tricky right now. I had to find a easy template, JSON template, to show you in the demo, since I was trying to translate another more complex template, and it doesn't work. It didn't work, so I had issues with that. But I think that this problem will be solved in a couple of months at maximum.
Okay, so Tiago, want to do the wrap up?
Yeah, I can do the wrap up. So let me just share here. So I just want to thank you, Marco, for the amazing session, and I just like to say that finally we have a new logo. Okay, so after a great thinking of like 35 minutes and finding a flag, we basically created a new logo that, let's see if this is the final one or if we're not going to tweak it a little bit more or not. To be totally honest, I'm not like totally happy with this, but we for all the community members, we if you guys want to contribute with a logo or something, we are more than happy to analyze it and get your feedback. But
maybe
basically
we can, Tiago, maybe we can do a challenge in 2021 for the Azure logo.
Well, why not? Okay, that's always a nice idea. Let's think about that. But basically this is it, and I would just like to say thank you for everyone, especially for Marco to be here today. And we have our next event next Wednesday, January the 13th, 2021. And we will have some fun again. Okay, so hope to see you all here again on that day.
And before we leave 2020, guys, just want to say that it was a different year, at least for all of us, for the community. We are going to send you guys some questionnaire.
A poll.
A poll. Yeah, thanks, mate. my brain is completely frozen today. We're going to send you a poll in the next few days to see what kind of subjects that you guys would like to hear in 2021, and also some feedback that we want from you guys about the community and how we can drive this community even further in 2021.